Algebra 1, number 4.2a, we're going to talk about the addition property of inequality. So, just as we solved equations using the addition property of equality to create a zero pair, we have -5, we add 5, it makes 0, and then we can eliminate it from an equation. We can use the addition property of inequality to solve an inequality. We solve the inequality for the solution set of the variable and graph the interval. What that means is we solve the inequality for the numbers to find out what it's less than or greater than or equal to, and then we write it in interval notation as the solution set for the variable, and we graph the interval on a number line, okay? That's all it's saying. So if we have x plus 4 is greater than 5, we use the addition property of inequality to make, whoops, I'm missing my y. We use the addition property for inequalities to make a zero pair, just like we did when we had an equation with an equal sign. So if we've got x plus 4 is greater than 5, we take 4 away from each side, and we can eliminate this 4, can't we? It becomes a zero pair, and it's gone. Now it's easier to see what's going on. 5 take away 4 is 1, so we've got x is greater than 1. So simple. All we have to do is make our number line and show that x is anything that's greater than 1. Now, it doesn't include 1 because this is not an or equal to. It's just a greater than. So it doesn't include 1. So we use a parentheses, and I'll explain at the end of this video why we don't use an open circle. Okay, that's silly. You should use a parentheses. And we draw the arrow showing, going to infinity, that these are all greater than 1. See? Our solution set is a parentheses 1, comma, infinity symbol, parentheses. And you can see the links in the description of this video. There'll be a link for video 4.1b that talks about this more and talks about how to do this more basically. All right? That was in the last unit. So, the addition property of inequalities, this is the formal definition of it. For all rational numbers a, b, and c, if a is less than b, then if we add a and c together, it's going to be less than b and c added together because a is less than b. And if a is greater than b, then when we add a and c together, then it's going to be greater than b and c. And similar statements are true for less than and equal to or greater than or equal to, okay? So our solution set for this problem down here is 1, infinity, all right? And because there's an infinite amount of solutions, we can check our answer by writing an equation from the inequality using an equal sign instead of the greater than sign. So our original problem said x plus 4 was greater than 5. It becomes x plus 4 equals 5. Now we can check this to see if we did it correctly. We substitute 1 for the x because that was part of our solution set, the 1. That was our cutoff point, wasn't it, for what is acceptable. And we get 1 for x here. 1 plus 4 equals 5 is true, so we know we solved it correctly. Now we can also check to see if the inequality sign is correct. We substitute any number greater than 1 because 1 was part of the solution set, and that's the cutoff point, right? So any number greater than 1, we plug that in to the inequality. See, now it's back to having an inequality sign. And the original was x plus 4 is greater than 5. So any number greater than 1, any number that's greater than this 1 in the solution set. 2 is bigger than 1. 2 plus 4 is greater than 5. That's true. 3 plus 4 is greater than 5. That's true. Well, our inequality sign is going the correct way. It's the correct sign. Okay? Let's see what happens when we have a fraction. All we have to do is just make common denominators first. And you remember how to do that, right? You just figure out which multiple they can meet at. And they can both meet at 12's house, so they can have 12 as a common denominator. We multiply 3/4 by 3 and 1/3 by 4, and we get 4/12 and 9/12, so now the denominators are the same. Now we can use the addition property of inequalities to create a zero pair and get rid of this 4/12. We'll eliminate this and make our inequality a lot simpler to look at. We subtract 4/12 from this side and get 5/12. Now we've got x is greater than or equal to 5/12. Now, because it's got this bar underneath here and it says it includes 5/12, we don't have a parentheses, we have a bracket and an arrow going bigger or equal to 5/12, showing that it includes the 5/12. That's why we use the bracket. Remember, the parentheses means it doesn't include it, okay? So this is our solution set, a bracket 5/12, infinity, parentheses, because we always put a parentheses next to an infinity symbol, okay? And the numbers that are larger than 5/12 go on to infinity, don't they? So that's our solution set in interval notation. And that video, 4.1b, I was talking about, the previous video, talks about interval notation, okay? So if you haven't seen it, check the link in this description and watch that one real quick, okay? So we check our solution by using an equal sign. This was our original problem with the common denominators now. We just substitute the 5/12 for x. 5/12 plus 4/12 equals 9/12, which is 3/4. That was our original, right? So we know it's true. We know we did it correctly. And we can check the symbol to substitute any number greater than 5/12. 2 is greater than 5/12, and the original said x plus 1/3, right? So we've got 2 plus 1/3. Well, 2 1/3 is definitely greater than 3/4, so we know it's true. See? All right, what happens when we have to collect like terms? Well, we look for the like terms. If you have to circle them, put squares around them, or whatever, you collect your like terms and you can group them together and combine them. Remember that the sign goes with them, and we got 3a minus 2a right here. Plus the 1 is less than -3. We combine these and we get our friend the invisible 1, don't we? That's the identity property. So now we've just got an a plus 1 is less than -3. So, using the addition property of inequality to create a zero pair, we get a zero pair right here. We eliminate this -1. We made our inequality a lot easier to write in interval notation because a is just less than -4. Now, it doesn't include -4, so we're going to use parentheses. So our solution set is -4, -infinity, because it's going to go smaller and smaller and smaller, heading into the negatives to the left. And because it doesn't include -4, we have a parentheses here, and then it goes that way. See? We can check with an equal sign. We put an equal sign into our equation, and we plug in -4. This was our cutoff number, right? We plug it into the equation, and we get -12 plus 9 is -3. Well, that's true. Just remember that a negative and a negative makes a positive, right? That's how we got the +8 there, all right? That's the inverse of an inverse. And there's a link for that in the video description too. We can check the inequality sign by substituting any value that's less than -4. -6 is less than -4. So we plug that in to the place where the a was, and we end up with -18 plus 13. See, two negatives make a positive. So we get -18 plus 13 is a -5. That is less than -3, so that's true. So look for this link in this video description to talk, so you'll understand about this. So we can use an open circle and an arrow going to the right and an open circle and an arrow going to the left to show a value is not part of the solution set. And you're probably being taught that in middle school. And we can use the filled in dot going to the right and the filled in dot going to the left to show a value is part of the solution set. But I don't advise this at all. This is going to confuse you and make it harder on you and give you more to remember. It's easier to use a parentheses with an arrow to the right or a parentheses with an arrow to the left on your number line to show that it's not part of the solution set, or a bracket to the right, bracket to the left to show it is part of the solution set, because we use parentheses and brackets to show our solution sets, to write our interval notation. When you've got it written on the number line already in brackets and parentheses, it's very quick and easy to write your interval notation for your solution set. It does include 1. It does not include 4. It does not include -1. It does not include 3. It does include 5 through positive infinity. It does include -2, and it does include 3. See? Because we write our interval notation this way, it's better to just do that on our number line to begin with. It's almost like when you were in 3rd grade and they said, oh, x is a times table. And then you got into middle school and they said, nope, x isn't times table anymore, a dot is times table. And you were like, what? Why didn't they teach me a dot is times table in the first place? Why are they confusing me? I don't know why they do that. I don't know why we use x for showing multiplying when we have to tell you later on, oh no, x is a variable. It stands for an unknown number. That is so confusing. Just teach it the way it is in the first place, and it'll avoid the confusion, right? I hope this was helpful. We're going to talk in 4.2b about how inequalities can be used for angles in geometry. It's going to be a real quick video just to give you an idea, okay? I'll see you there. Bye.